Welcome back, everyone. Today we're diving into a fascinating look at manufacturing and AI. Why, um, there hasn't exactly been a ChatGPT moment for manufacturing yet. It's really all about the deep underlying infrastructure, like geometry kernels in CAD tools.
Yep. So let me get this straight. While AI has revolutionized writing and code generation, manufacturing is still stuck with these legacy systems in design, right?
Exactly, yeah. It's like imagine a factory floor that's only a piece of a bigger puzzle. The real story starts with how engineers design parts. Even in 2025, a turbine blade is still designed using the same old CAD workflows from decades ago.
Mm-hmm. Right. And a lot of that stems from the so-called geometry kernel, correct? That's the engine behind how 3D models are formed.
Exactly. The geometry kernel is the secret sauce. When you draw a circle in your CAD tool, it's not just about pixels, it's about defining a precise mathematical object with all these constraints and relationships, much like how Lego bricks um, can only snap together in specific ways.
Yeah, I see. It sounds like these kernels really form the backbone of all manufacturing design, from turbine blades to, say, automotive components. But why is AI struggling to leap in here?
Well, think about it. AI like ChatGPT has a massive corpus of text or images, but manufacturing data, actual design files with real world tolerances and material properties, is fragmented. The whole system is riddled with disconnected
That's
workflows.
interesting. So these, design files get lost in translation? Like converting a document from one format to another, but with far more catastrophic consequences?
Exactly right. It's like converting a Word document. One moment you have beautiful structured text, and the next formatting breaks and images shift. Except here, a slip up might lead to manufacturing defects costing tens of thousands of dollars,
Mm-hmm.
or even worse.
Wow, that really puts things in perspective. And the proprietary nature of these geometry kernels only adds to the problem, doesn't it?
Right again, the market is dominated by just a handful of players who've got these kernels locked down for decades. Industries like aerospace and automotive are deeply tied to specific kernels. Switching isn't really an option, given the legacy libraries and the trust built over years.
Yeah, for sure. So, this lock in hinders innovation because any breakthrough AI design tool still has to operate through these established, constrained architectures?
Absolutely. Even though AI can generate, say, optimized designs or even help reduce design cycle times, they're still bottlenecked by these underlying systems. It's like having a high performance sports car, but being forced to drive on a dirt road.
Indeed. I'm curious. Why haven't we seen a real breakthrough moment like, ChatGPT for design? Is it just these legacy constraints?
Largely, yes. With manufacturing, there's a need for an AI system that not only understands geometry, but also integrates physics and manufacturing constraints in real time. Until there's a system that can handle both design and the practicalities of production, the sector remains fragmented.
Mm-hmm. It's almost like the AI in manufacturing needs to be a true multitasker. From math modeling to understanding real-world material limits. That's a massive challenge.
Exactly, and that's where we see the strategic differences between the US and China emerging.
Right. Oh, interesting. So, how are these strategies diverging?
In the US, we've got lots of companies and startups trying incremental improvements using existing proprietary systems. Think Autodesk and PTC integrating AI into their workflows, but all built on those
Yeah, I
foundational
get that.
kernels.
While in China, it seems like there's a whole different ballgame, building an integrated stack from the ground up.
Yes, exactly. China is pursuing a multi pronged strategy, strategic acquisitions, like with ZW Soft developing its overdrive kernel, international partnerships that tap into Russian expertise, and a significant push for open source enhancements like
Yeah,
Huawei's
that's
OGG
fascinating.
initiative.
So, while US firms are working within the old rulebook, China's kind of rewriting it completely, right?
That's it. By building on open foundations and even open sourcing kernel enhancements, China is trying to break free from dependence on
Mm-hmm.
Western controlled systems.
But don't you think there's a risk, though? I mean, challenging established systems, aren't there critical reasons why these proprietary kernels remain dominant, like reliability and engineering trust developed over decades?
Absolutely. And that's a key critique. The US perspective holds that these kernels are battle tested. They've been refined over time through real world failure and success. The criticism is that while China's approach is bold, its new systems still need to prove they can match the precision, reliability, and robustness of the incumbents.
Right, I totally understand. So, it's a high risk, high reward scenario. The US strategy may be stagnant, but it offers reliability, whereas China is trying to disrupt with something new.
Exactly. And the implications are massive. Whoever cracks this, developing an AI system that truly integrates geometry, physics, and manufacturing constraints could reshape the entire manufacturing landscape. Imagine collapsing design to production cycles from months to days.
Wow, that's a game changer. And that would, in turn, potentially allow mass customization on a scale we've never seen. Smaller companies could compete with, um, industry giants without needing huge armies of CAD engineers.
Right. Essentially, the prize isn't just efficiency, it's about redefining how industrial design and production interact. But achieving that means overhauling the entire geometry layer by, which is an almost insurmountable challenge under current conditions.
Mm-hmm. Yeah, and it sounds like making that leap would require, extensive public investment and a coordinated push. There's talk of specific policy proposals to fund a new open geometry kernel for certain high volume applications, like injection molding. Is that right?
Exactly. The proposal suggests a focused initiative specifically aimed at critical sectors. For example, injection mold design with a kernel optimized for generative design, deterministic operations, and robust tolerances. It's not about matching every feature of Parasolid, but achieving a leap in design speed and reliability.
Interesting. But isn't there some risk that such public investment might end up with a system that still lacks the market traction because of industry inertia? Manufacturers might be hesitant to switch if they've got, decades of legacy data on current systems.
That's a valid challenge. The proposal does concede that transitioning to a new kernel would require rebuilding legacy libraries, retraining engineers, and overhauling workflows. Essentially, a massive coordination effort,
Yeah, that's a
possibly
steep
through a
hill to
nonprofit
climb.
foundation.
I see. So, we have a situation where the US manufacturing sector might be, uh, structurally inhibited from pushing AI innovation due to these locked in systems, while China is methodically creating an alternative model from the ground up.
Exactly. The strategic implication is huge. It's not just about improving CAD tools, it's about who will control the interface between digital design and physical manufacture in the coming decades. That layer becomes a critical infrastructure.
Absolutely. And that could determine the future global competitiveness of entire industries. It's almost like a new industrial revolution based on computational geometry.
Exactly. Yeah. We're looking at a shift where the language of manufacturing becomes um, that geometry kernel. Whoever masters it sets the standard for, you know, everything from aerospace to heavy machinery production.
Right, that's powerful. So, in a way, the real ChatGPT moment for manufacturing might happen when AI can truly integrate with this foundational layer, instead of just adding, clever automation on top of old processes.
Bingo. The breakthrough we need is an AI system that understands and can um, manipulate geometry at a kernel level with practical production feedback. Until then, we'll keep seeing only partial, incremental improvements rather than a full-blown AI revolution
Yeah, that
in
makes total
manufacturing.
sense. This conversation really opens up the bigger picture. Not just technology, but how strategic policy and international competition shape manufacturing's future. It's exciting and a bit concerning at the same time.
Absolutely. The stakes are high. Reimagining manufacturing means overhauling a system built over decades. Whether through coordinated public investment or market-driven competition, the decisions made today will shape our industrial landscape for years to come.
Exactly. It's a fascinating intersection of technology, economics, and international strategy. I'm looking forward to seeing how this unfolds, especially given the potential rewards if someone cracks it.
Me too. And that'll be the moment when AI truly transforms manufacturing, ushering in rapid, reliable, and scalable design to production pipelines. Until then, it's a story of slow evolution
Right
and
on.
strategic contention.
Thanks for breaking that down. This deep dive into the challenges at the foundation of manufacturing really puts things into perspective.
Absolutely. Thanks for joining the discussion. We'll keep an eye on these developments as they redefine the future of manufacturing. Catch you next time.